5.28. Hope you have your notes out. You ready? All right, polynomial functions. Does anyone know what a polynomial is? Can you just... Two what? Poly means many. Sort of. I'll tell you. Yeah, I don't know. We'll do lesson, then I'll tell you how much. Okay, a polynomial function is of the form f of x. I'm going to write this down, and then I'll explain it. So just write it down for now. No. Just write it down and then I'll tell you. I'll explain the whole thing.
Is that an R in it?
Where? It is. It actually is a math thing.
I can't learn one math.
Okay, here's what it says. F of x. Okay, it's talking business is not going to work. It says f of x equals a sub n, that means like subscript n, x to the n plus a sub n minus 1 times x to the n minus 1 plus dot dot dot. That means this pattern continues where the dots are. Plus a sub 1 x, this is understood to be to the 1, plus a sub 0. Now, what this means is this a sub n minus 1, those are just coefficients, so those are just numbers. But the reason we identify it as a sub n is because this is the number that's in front of the nth power. So it's just a way to write this out arbitrarily, meaning for any numbers you could think of, for any kind of polynomial function, they'll all have this form. So it's just a way to sort of identify what kind of functions would be polynomial functions. So for instance, an example of a polynomial function might be 2x squared. It might be 2x to the 17th plus 5x to the 16th plus 9x squared plus 2x plus 7. Any of those would all be polynomial functions. So it's just saying that we have some power, x to some power, and then it's counting down, one less power, until you get to a sub 0, which is just a number. Here's the important thing to know. A sub n, the number that's in front of the highest power of x, is called the leading coefficient. You need to know that. It's going to come up time and time again. So the number in front of the highest power is the leading coefficient. Now, technically I could write these out of order. So it's not necessarily the first number, which some students like to just jump to that. Oh, it's the first number. But it's only the first number if they're in order, by power. Okay, the other thing is that n, the highest power of x, is the degree of the function. Again, this is going to come up a lot, so you need to know that. A sub 0, this one that actually doesn't have any x, we could think of this as x to the 0. What is x to the 0? 1. So it still follows the pattern, right? X is counting down to 0. All right, this is just a number, so it's called a constant term. What we would call just a number would be a constant. The biggest thing to know is that the exponents are whole numbers. And they all have variable bases. So when we think about an exponent, you have a base and an exponent, right? 2 to the 3. 2 is the base, 3 is the exponent. So these all have variable bases, which means the x is the base. That's our variable. Does everyone follow that? Okay, yes. It depends on what this n is. See, that's why we really can't tell, but it's going to continue on until you get to 1 and 0. Okay, so let's look at a couple of examples. Let's have h of x equals x to the 4th minus 1/4 x squared plus 3. And my question is this a polynomial? Okay, so the two things we need to look for. That the exponents are all whole numbers. Are they? Yes. And the variables are all in the base. And those are as well. So yes, this is a polynomial. Okay, g of x equals 7x minus root 3 plus pi x squared. And I want to know is this a polynomial? So what two things are we actually looking for? Variable bases and exponents are whole numbers. In fact, there should be positive whole numbers. Let's go ahead and write that in. Positive. Okay, so are they all positive whole numbers on the exponents? Yes. Are the variables all in the base? Yes. An example of something that wouldn't have, actually, I think we have an example, so we'll get there. I'll show you an example of what it would look like to not be. So even though this has a square root 3 and it has a pi, those are the coefficients. So that's okay, as long as they're not in the exponents. Okay, next, f of x equals 5x squared plus 3x to the negative 1 minus x. Is this a polynomial? No, why not? Because the negative 1. So they have to be positive. The exponents have to be positive whole numbers. Because remember what happens when we have a negative exponent? What can we do to make it positive? Put it in the bottom. But see, that really doesn't follow the pattern, right? Okay, so this is no, not a polynomial. Okay, and then we have k of x equals x plus 2 to the x minus 0.6 x to the 5th. Is that a polynomial? Why not? Okay, because the x is in the exponent. So this is a case where you would have the variables are not all in the base. This has the variables and exponents. So it actually breaks both rules. Because the first one says that the exponents must be positive whole numbers. But is this a positive whole number? No, it could be anything, right? It could be a fraction, it could be negative. So no, not a polynomial. Okay. The second rule is that the variables have to be in the base. So x to a power, x squared, x to the 5th, not 2 to the x. So the exponents have to be positive whole numbers. Yeah, you don't. It could be anything. Yeah. Okay, so looking back at these four, actually the first two, for the ones that are polynomials, I want to know what is the leading coefficient. So looking at this first example, we know that the leading coefficient is going to be the number in front of the highest power. Yes, it would be 1. Because the number in front of x to the 4th there is a 1 there. We just usually don't write it. Excuse me, does everyone see that? Okay, what is the degree? So the degree is the highest power of x, and what is that? 4. Okay, so it's important to keep these words straight, vocabulary-wise, so you know what they're asking for. It's not hard. You just have to remember what the words mean. So the degree is the highest power of x. The leading coefficient is the number in front of the highest power of x. Make sense? All right, number 2. Since this is a polynomial, it also has a leading coefficient. What is the leading coefficient? Pi. Some of you wanted to say 7. It's really easy to go to, oh, that's the first one. But notice that this one isn't in order by power. If we put it in order by power, it would be pi x squared plus 7x minus root 3, and then we clearly see that the leading coefficient is pi. So So make sure that you're careful about that. And then the degree of the function. What is the highest power of x? 2. Are you good? Awesome. You're going to practice some of these on your own. We'll see how good you are. Okay, so same thing. I want you to tell me, is it a polynomial? And if so, I want you to tell me the leading coefficient and the degree. Okay, Andrea, what do you think about number 1? Yes, it is a polynomial. I agree. Kevin, what is the leading coefficient? Sure.
1.
On 1, yes. -2. So, yeah, just be careful about that if it's not in order. And if we put it in order, it would be -2x plus 3. Do you agree? 13. -2x plus 13. Okay, yeah. So it would be -2. Great. And then, Michelle, what's the degree? What? 1, yes. Very good. Questions on 1? Okay, number 2. Owen, is it a polynomial? No, you got off easy. So there actually isn't a leading coefficient or degree. All right, Cameron, what about 3? Yes. And for the leading coefficient, let's see, Siana. Is 6, yes. And for the degree, Marissa. I'm so glad y'all got the good ones. Yes, go. Why do you think it would be? This says equals 6x squared. It's okay. I know, sometimes it's a little bit fuzzy. I don't know why. Okay, awesome. Any questions on these? Perfect. All right. Direct substitution. I could probably do that a little. Okay, we have done this before. We've evaluated functions at a certain point. Like maybe the question will say, if we have some function I want to know, what is this equal to when x is equal to 2? We've seen these before, yes? Maybe with different kinds of functions, but we've seen this type of question. And what do we do every time? Plug it in. And we're going to, it's called direct substitution, that's its official name, but we're going to be doing this every time. In the book, it talks about synthetic substitution, which is the reason why it calls this direct substitution, but this is the same thing we've been doing. Don't be scared. Okay, if we wanted to figure out when x is 2, we would have f of 2 equals, and then I always go through and put parentheses wherever there's an x, and I think we've talked about this a little bit before. So parentheses cubed, plus parentheses squared, minus 15 parentheses, minus 15. Putting in the parentheses where there's an x will avoid the issue of if there's a negative number. So, for instance, we're going to go back and do this when x is negative 2. And the parentheses will help us. So let's do 2 first, and then we'll talk about negative 2. So now I'm going to plug in what I'm trying to evaluate. Now, you could follow the order of operations and figure this out, or you could put it into your calculator. But you need to be very careful that when you put in your calculator, you use the parentheses just like we just did. So enter this in exactly. So if you have your calculator, go ahead and get it out. Huh? Oh no, so, okay, what we're going to get is that f of 2 equals a number. The number is what we're actually trying to find. F of 2 is just indicating that this is what the function is worth at 2, or its value, not what it's worth, but the function's value at 2. Okay, so the f of 2 is just what we're looking for. This is saying, what is the function value at 2? So what we're about to find, the number here, is what we're looking for. F of 2 just tells us what we were doing. It is a 3, yes. Yep. You can use mine. This one. You'll be right. I think it probably is when you type it. If you don't have a calculator, make sure that you bring it. We will be using it. It's weird. I know. Well, I know first semester we don't use it a ton. The second semester we use it almost every day. Okay. Kelsey, do you have an answer? Negative 65. Anyone get something different? You're good? Any questions? Awesome. Okay, what would happen when x is negative 2? So we'll call this, I don't know, example A and B. So now we have f of negative 2. And again, I would say you should go through and just put parentheses first. So negative 3 parentheses cubed plus parentheses squared minus 15 parentheses minus 15. Then we're going to go in and plug in this negative 2. Here's what I want you to see. Right here, if I didn't put the parentheses and I just thought of it as negative 2 cubed, what is negative 2 cubed like this? It's negative 8. What is, no, sorry, I'm lying to you. This is the wrong one. They're actually both negative 8. This one right here, if I didn't put the parentheses and I just put negative 2 squared, what is negative 2 squared? Negative 4. What is this negative 2 squared? Positive 4. So it's going to give you a different answer if you don't put your parentheses in correctly. So make sure you do your parentheses. Okay, enter this into the calculator, just like it is. Are you good? Okay, Molly, what'd you get? 43. Everybody get 43? Awesome. Do you want to practice more of those, or are you good on those? You're good? You want to do another what? Huh? Your homework? Well, we have more to do.